Yes! I'm cruising.
This
What are you
is
doing,
tough.
Mr. Kent?
This one's a hard one.
I'm cruising. I'm measuring angles. I'm making things happen.
God. How many points do you have?
I have about 10,000 points. Hello there. How is everybody? We're just getting our Khan Academy on. This is Mr. Athmer,
Mr. Kent?
and welcome to another rousing day of DC-CAS test prep. As you can see, we're having a great time with Khan Academy. It's a great way to boost your skills. It's a great way to get competitive and make things happen. I want to see your name up on the energy point board. Mr. Kent's class will be up there as well. And the person at the end of the semester with the most energy points is going to get a Chipotle burrito lunch. So make things happen. And Mr. Kent, why is Khan Academy good for you?
I really like it because I'm able to work on, what I need to work on. This is a time for me to really work on my skills that I feel like I have to get ready before April.
And where can you work on this?
I can work on it at home. I can work on it during class when I'm in my station, when our Khan Academy station. I can also work on it after school in your room or mine.
I love it. Good work. I have a tough problem, though, that we need to go over. So let's go over to the whiteboards. Mr. Kent can make my memory come back to me, and I'm sure I can as well. We have special right triangles today. And like always, let's start off with some vocabulary. When you hear the word or the term special right triangle, let's piece some things together. Special, what does that mean to you? To me, it means unique. For something to be special, it has to be unique. Has its own properties. So if something's unique, it has its own properties. It's special, okay? So now let's go to the term right triangle. That's very simple. It's a triangle that contains a right angle, a 90-degree angle. And you all know what that looks like. And say, let's have one that looks like this and has that box. Boom. Right triangle. Because we know the box means 90 degrees.
They come in all different shapes and sizes.
Mr. Kent, you draw another one. Draw another right triangle. It might look different than mine because we're all unique. We're all special. Check that one out.
Boom.
Piece of the box, right triangle. Vocab complete. Good job. Now, we have two types of special right triangles. The first one is called a 45, 45, 90. And you're going to hear that term a lot. That just means that a triangle has a 90-degree angle, boom, and two 45-degree angles, boom, boom. A 45, 45, 90. And you're going to see a question on the DC-CAS that looks like this. What is the length of segment AB? First, let's identify segment AB. It's right here. We're missing the measurement, so we got to find it. And we can, again, identify that's a 45, 45, 90 because they give that to us. More times than not, they will give you the degree measures so you know exactly what type of special right triangle it is. And so we've been working on these a lot in geometry and in other classes. Let's think of it in a different way, a higher level way that you might see in trig functions or pre-calculus next year. So the first step is to always draw a reference triangle. A reference triangle. And what does that mean? Reference just means to imitate, to use as a support, a reference. So we're going to draw the same exact triangle that we see above. Do your best. Mr. Athmer sometimes makes his look goofy, but make it look the same.
And notice
the
how
right triangle.
Mr. Athmer's labeling our angles. It looks exactly like our initial question. But what's going to change, Mr. Athmer?
Well, now we need to make it our reference triangle. This side we're going to make 1, and this side we're going to make 1. And why are they the same? Because they are across from the same measured angle. 45 degrees, side length of 1. 45 degrees, we know it has to be the same side length of 1. And then up top, across from the 90-degree angle, which is called our what? Our hypotenuse, we're going to make it square root of 2. And we're going to pause the video for a second, and we're going to see if you know why this reference triangle works out. Okay? Next up, we have our reference triangle, and now we need to solve our actual question. What is the length of AB? So we're going to set up proportions. A proportion sets two ratios equal to each other. So let's see what we can do with this thing. All right? We know up here on our question triangle, side length AC is 12. We know on our reference triangle, AC is square root of 2. So on top, I'm going to put our real triangle, thank you Mr. Kent, helping out teamwork, and put it on top of our reference triangle. Our question triangle and our reference triangle. So we need to set it up the same way with our other two sides, or with one of our other sides. We have our real triangle, which I'm just going to label x. They don't do anything for us, but you know what x means. It's a variable. It's a placeholder for an actual value. So I'm going to put x on top, which is our real question. Put it over the denominator, which will be our reference triangle, which is 1. So now we have a nice little setup, a proportion.
So we're trying to solve for our missing side here, and what we've done is we've set up a proportion where we know every single value except for that missing side.
So now you know how to solve for a missing value in the proportion. We can cross multiply. You all know how to do that. So 12 times 1 equals square root of 2 times x. Alright? So now let's simplify by doing our operations. Mr. Kent, why does it look like this? What did I just do here?
That property that you just used, here we had square root of 2 times x, and now we have x times square root of 2. We've just commuted and moved those numbers around. You just used the commutative property.
Great. And that's what they typically look like on exams and tests and DC-CASs. They're going to look like this. So that's what I did. So now all I need to do is get x by itself. So I divide by a square root of 2. Divide by a square root of 2. These cancel, and I'm almost done. Mr. Kent, do you mind if I take a blank whiteboard?
Go for it.
All right. So we're left with this. These cancel. Now, I have x equals 12 divided by square root of 2. We know that's ugly. We don't want that. So what could we do? What can we do? We can rationalize the denominator by multiplying the top and the bottom by a square root of 2. Is that correct, Mr. Ken?
That's correct.
Awesome.
And the deal is most mathematicians, they don't like having the square root in the denominator. And so when we say rationalize the denominator, all that means is get rid of that square root in the denominator, and this is how you do it.
Awesome. So let's combine or do our operations. 12 times square root of 2 is 12 times the square root of 2. And the square root of 2 times the square root of 2 is the square root of 4. I'm going to write that out for you. And that's pretty simple because guess what? Square root of 4 is just 2. And we're almost there. We're almost there. What's 12 divided by 2? 6. Does that check out, Mr. Kent?
Looks like it does. So all the way back up here, our x's are going to be 6 times the square root of 2. So they're both going to have lengths like that. All right.
And there's one special right triangle.
Awesome job, Mr. Athman. We got one more example for you. That's the other flavor of special right triangles. 30, 60, 90. Okay? And just like we call 45, 45, 90 triangles because of their angles, 30, 60, 90s have those properties as well. So here we're dealing with a triangle. It's a right triangle. And we're told that angle x is equal to 30 degrees. Okay? So as I'm reading the problem, I'm going to be filling in my information with my triangles. Angle x, well, here's x. And here's angle x. So that's going to be 30 degrees. And if I know this is 90, this has got to be my 60. All right, and if we add them all up, that adds up to 180 degrees, which is the number, what the angles sum to in a triangle. So I know that angle x is 30 degrees, and I know segment xz is 11 centimeters. Okay, so I got to find x and z, and the line between them, here it is, that is 11. Okay, and just right off the bat, I know that because xz is across from my 90-degree angle, this is my hypotenuse. So same steps as Mr. Athman was walking through. Our first step is we want to set up a reference triangle. Okay? And so to do that, draw the exact same picture that you're seeing up here, except we're going to fill in a little bit different sides. So here's my right triangle here. Here's y. Z is down here. X is up here. And I know here we got 30 degrees, and here is 60 degrees. Okay. So, instead of using 11 out here, I'm going to locate the smallest side on this triangle. And I know the smallest side is going to be across from the smallest angle. So here's my smallest side, and I'm going to label that 1, because 1's an easy number to work with, and I like that. I'm also going to fill in the rest of my reference triangle. So if the smallest side is 1, your hypotenuse in this special right triangle is going to be 2, or 2 times the size of 1. And then our second longest angle is going to be the square root of 3. Okay, so here's my reference triangle. Okay, second step is to set up your proportion. Okay, and so we're going to compare our reference triangle to the real triangle. Okay, so I got to go to the question to figure out what do I want to find. I want to find how long is xy. Xy is this side length right here. So I need to figure out what that side length is. I'm going to call that I don't know, let's call it q. Okay, I'm going to solve for q. All right, that's that length right there. So I'm going to set up a proportion with the things that I know. I know this is 11, so I'll go ahead and put that on in the numerator, and I'm going to compare it to my reference angle. Well, this side matches up with this side, so 11 divided by 2 is going to be equal to, I want to solve for q, and q's in my question, so q's up here. Q divided by, what does it match up with? Square root of 3. You got it. Okay? So now I'm trying to solve for my missing value q, and to do that, we do our cross multiplication. All right? This is just an easy step that takes care of a couple math operations in one. So we get 11 times the square root of 3 is equal to 2 times q. And remember, keep in mind, we're always trying to solve for q, a missing side. Okay? So I have 2 times however long that side is equal to 11 times the square root of 3. And my last step will just be to divide by 2 on both sides because I'm trying to get q alone. That will cancel here. And I get q is equal to 11 times the square root of 3 divided by 2. Mr. Athmer, is that a pretty number?
That's pretty to some people.
Yeah.
But guess what I also like to do?
What do you like to do?
I like to simplify this even more. 11, because I like to work with decimals as well.
Okay.
That's
all right.
11 divided by 2.
11 divided by 2. Well, 11's an odd number, so I'm going to split it in half, so I must be getting a decimal somewhere.
Awesome.
I think 5.5 times the square root of 3.
And guess what? They're the same thing.
Same number. Any way you like to write it, you can go for it. Okay? You got a couple practice problems? Go blue. Go kick some butt.